Solving systems by substitution. How do we solve system by substitution? Well, first we have to remember what substitution means. It means that we are going to replace something. We also have to remember what a system of equation is. A system is more than one line. So if we took this line, y equals 3x plus 1, and we put it together with y equals negative x plus 5, and we graph them on the same coordinate plane, we would end up with a location that would satisfy both equations. In other words, we would get an ordered pair that is part of both solutions. And we can see that if we plug that in. For example, if I plug it into here, I'd have 4 equals 3 times 1 plus 1. Here I'd have 4 equals negative 1 plus 5. And we know that 3 plus 1 does equal 4, and negative 1 plus 5 does equal 4, so that this part is true, and we see where it collides. Now we can graph this and do all that, but that would require to make sure that we're very exact in our points and our plotting, and it can cause some mistakes. So there's one method also for solving a system, and it's called by substitution. And basically what's involved is that we use one equation to solve both equations. So this is primarily what I'm talking about. If you have two equations in the system, x plus y equals 5, and x equals y plus 1, we're going to take what one variable equals, this equals y plus 1, and we're going to replace it here. Take this and actually replace it. Now, when we do that, we're going to write ourselves a new equation. We're going to say, instead of x plus y equals 5, we're going to say y plus 1, which is what we're replacing, right? I'm going to put a box around it so everybody can follow along. And then plus y equals 5. So basically, I've just written this first equation, but in a single variable because I've replaced the x with the y. So by doing this, now I can just combine like terms. Change colors here. 2y plus 1 equals 5. Then I would just solve. Subtract 1 from both sides. I'd end up with 2y equals 4. Then divide both sides by 2. And find out that y equals 2. Now, because, as we just remembered a moment ago, that our answer is going to be an ordered pair, that means we found the y part of the ordered pair. So, build our ordered pair, put the answer in the y spot. Now I can choose, I have to go back to the original two equations that are part of the system, and I'm going to plug in 2 into one of them. It doesn't matter which one. I'll take this second one here, and I'll say x equals 2 plus 1, and then I solve for x and find out that it's 3, so my ordered pair is 3, 2. And that's the basic idea of solving by substitution. Taking what one variable equals in one equation, substituting it into the other equation, so that we end up with an equation that has only one type of variable, maybe more than one there, but one type, so that we can combine terms and solve for that particular variable. Okay, we're going to do it again here. Same idea. We're going to take this y plus 2 because x equals that, and we're going to replace it or substitute it into the top equation. So when I go to rewrite this equation, instead of writing x plus y equals 6, I'd write y plus 2 plus y equals 6. And again, there is that replacement. I'm going to put a red box around it so you can see what I've replaced it. I put that in there and just dropped it inside there and gave myself a new equation. Okay, let's continue to solve this. We're going to collect like terms, so we have 2y plus 2 equals 6. Start out by subtracting 2 from both sides. 2y equals 4. Divide both sides by 2. And end up with y equals 2. And again, our answer, our solution, will be an ordered pair. So put 2 in the y spot. And again, go back to the original equations and choose one of them. I'm going to choose the bottom one. X equals 2 plus 2. Find out that x equals 4. So my ordered pair where these two lines will cross is at positive 4, positive 2. Now let's switch it up a little bit. Here I have two equations, y equals x plus 2 and y equals 2x minus 1. Now because they're both y equals, basically what we're saying is that we're going to set them equal to each other. So let's rewrite that. 2x minus 1 equals x plus 2. Now we have variables on both sides. We have to decide if we're going to keep the 2x or the single x. We're going to keep the 2x and we're going to subtract the single x from both sides. That way we'll always end up with positive variables if we keep the larger of the two. 2x minus x is x minus 1 on one side, and that would leave us just 2. Then we'd go ahead and add 1, and we find out that x equals 3. So again, we're building that ordered pair, and this time we're finding x first. It doesn't matter if you're finding the x or the y first, as long as you're just getting one variable and not two different variables. We can go back to either equation, because remember, we always go back to the beginning. I'm going to take the top one here, that first one, y equals x plus 2, and substitute 3 in place of the x. Find out that y does indeed equal 5. So the solution to this system is the point 3, 5. Now these work out really nice and simple when things are laid out a little bit better. But when they're not laid out, when they're not laid out, let's take a look at this. So this one here says 3x plus 4y equals 2 and 2x minus y equals 5. Well, since neither one of these equations is set up with a variable by itself, we're going to have to manipulate an equation to make that happen. Well, in this first equation, I have 3x's and 4y's. Doable, but I'm going to end up with some fractions. Probably not the best scenario. Here I have a 2x and a negative y. This is probably the easiest one to manipulate to get the y by itself, so I won't have any fractions to deal with. So I'm going to take this equation, 2x minus y equals 5, and I'm going to manipulate the equation. I'm going to subtract 2x from both sides. That way I'm going to get the y by itself, and in this case it's negative y at this point. And then I'm going to divide everything by negative 1, because this is telling me the opposite of y equals that, and I want to know what y equals. So y equals 2x minus 5. So what I'm going to do is I'm going to take this y equals 2x minus 5, and I'm going to drop it in the y spot up there in the first equation. Because I manipulated the second equation, I have to go back to the first equation to substitute. So I'll end up with 3x plus 4 times 2x minus 5, and that equals 2. Again, one variable. We should always have one variable when we rewrite. If we don't, we did something wrong. Okay, I'm going to distribute that 4 out. So that'll give me 3x plus 8x minus 20 equals 2. I'm going to collect like terms. 3x plus 8x is 11x minus 20 equals 2. Add 20 to both sides. Find out 11x equals 22. And divide both sides by 11, and x equals 2. So far in my ordered pair that I am building, I found out that x equals 2. I need to figure out what the y is so that I can complete my ordered pair. Now, when I find out what y is, I'm going to have to go back to the beginning. Remember, we always go back to the beginning. We don't want to work with an equation that we manipulated, because if we manipulated it wrong and we try to get an answer, it just makes it even more wrong. We'll catch wrong answers if we always go back to the beginning. I'm going to choose the first equation just because I like things more positive. So 3 times 2 plus 4y equals 2. And we're going to solve for y. So 3 times 2 is 6, plus 4y equals 2. We'll subtract 6 from both sides. Find out that 4y equals negative 4. Divide both sides by 4. Slide it down a little bit. And find out that y equals negative 1. So then I'm going to put a negative 1 in that spot. And there's my ordered pair. 2, negative 1 will solve this particular system of equations.